I have been coding with AI since 2022, and I have been using Claude Code since the early beta release in February of this year. And now I also teach real product teams how to actually ship features using AI in my agentic engineering workshops. And the difference that I see between teams that struggle and teams that successfully adopt AI is not the tools that they use or the models, it's the principles that they apply and the systems that they deploy. I'm Rasmus, and I was vibe coding way before it was named vibe coding, and I was context engineering way before context engineering was even a thing. I have tested everything from Claude Code to Copilot, and I have an AI bill of several hundreds of euros per month. I have shipped many projects with AI, both solo and in a team for real clients in real production environments. And now I teach these principles and what I learn to other teams and here on YouTube. I work with a wide range of people. Anything from vibe coding AI enthusiasts to senior software engineers who are really skeptical about the value of AI and especially the value of AI for coding. And look, I get it. I watched experienced engineers struggle with AI every day. And it's not because they're bad engineers, they're actually brilliant. But working with AI for coding requires a different approach. And not many are teaching that. You're either figuring it out alone or you're stuck at only utilizing about 10% of AI's actual potential. Some of the most common mistake that I see both vibe coders and engineers make is that they are vibe coding and expecting it to work without providing clear guidance to the agent. Or they are treating AI like a smarter autocomplete and going back and forth all the time, not really knowing when to stop, and then spending more time debugging the AI code than actually it would have taken writing it themselves in the first place. Or even worse, they're not using AI at all because they have seen it fail too many times, or they have heard from someone else that AI is not there yet and it can't code. So today I'm sharing my top 7 tips that actually works, that I see real engineers use on real production projects every day. No fluff. No copy paste this magic prompt to solve all of your problems. Just the patterns and the systems that I see working for real teams shipping real code in real projects. So let's jump right in. Tip number 1. And this one is so simple, yet I see so many people skipping this one. And it's really learn the tool that you're using. Really deep dive into the tool and learn its features, learn how it works, learn what it can do and what it can't do. And this will really help you scale up your AI coding. Something that I see constantly is people using Claude Code or Cursor for months, never really knowing how to really use it. They are spending more time watching YouTube tutorials or listening to someone else than actually reading the documentation and spending the time it actually takes to learn about the features. They're copying someone else's prompts or workflows rather than creating their own. And this goes for whatever tool you're using, not only Claude Code or Cursor, but whichever tool is your daily driver, make sure that you spend the time to learn that tool, actually understanding how it works, how the memory system works, how you can store prompts to reuse them later on. Really dive deep into all of the new features, like how the hooks work, if they have sub-agents, how you can use the agents to run autonomous tasks for a long time, and so on. The reality is that most people just scratch the surface, and they use maybe 10 to 20% of what the tool can actually do. It's basically like buying a Tesla and never really trying the autopilot functionality. So what can you actually do practically? Here I have my PRP's Agentic Engineering repo. This is where I share most of my resources for Claude Code. In here I have one folder where every Thursday I update this to have the latest documentation from Claude Code, so that I can go in here and I can chat with the docs and really learn about every new feature. So I spend 15 to 20 minutes every Thursday to chat about any new feature that I want to learn more about. I build some examples, I try it out, and I really try to dig deep and see if there is any use case for any of my existing projects where I can implement these new features. Now we're here, we have the repo open, we can just launch up our terminal, we can launch Claude Code, and we can start chatting away with our docs. So we can just take, for example, say that we want to chat with the hooks, something that I have wanted to do. I've been on vacation most of July, so I haven't really dug too deep into the hooks functionality. So I can just do this. Please teach me about Claude Code hooks and list me at least 10 use cases. And I'll just give it a relative path so that it will go and look for the document that we have, this actual sharding. So you can see here it reads the entire file. It's 1300 lines, and it will start thinking about the use cases. You can also tell it things like think hard, think ultra hard, research online for other use cases, and so on. You can use it to build out some examples so that you can really dig deep and learn more about the feature. Now, knowing your tool, that is step number one. But you also now need to teach your tool or your LLM your way of working. And this is where the rule files comes in. So tip number 2 is master your rules file. So whatever tool you're using, you're going to have some sort of rule system or memory system. With Claude Code, this is the claude.md. And you can think of your rules like your agent's long-term memory. But what I see a lot of the time, that most people either they don't have one, or they set it once and then they forget it and never update it again, or they copy someone else's rules file into their project hoping that it will work for them as well. And these are all mistakes. So every time you see the AI make the same mistake twice, add it to the rule file. If it's using the wrong import style, add guidance to the rule file. It's over-engineering on a specific topic, specify it in the rule file. Or is AI forgetting how your specific error handling or your specific naming standard patterns work? Add the guidance to the rule file. So without rules, you're forcing yourself to have to explain and explain over and over again. And it's like training a new developer every time you have a new task. But yeah, remember that the agent might still forget your rules, and it might not check the right part of the rule files before it starts a new task. But what makes it so good to have it in there is that you can always reference it, and it's always there. You don't have to rewrite it into every prompt. You can just say, make sure that you follow the standards in the rule file, and you can point it towards either the entire rule file or a specific section of your rule file. Here we are in the repository again. Let me just show you a really simple example. Open Claude Code. And I'm just going to simply tell it, please run main.py. And you're going to see here that it's going to start running it, and it's trying to run it with our Python main.py, which is not going to work because we are, either it has to run it with Python 3, but we are actually using UV in this project. So just add hashtag in the beginning, and then you say always use UV run to run a script, and we'll see it, add it to project memory. It's here. We can now exit, we can clear, we can open Claude again so that it loads the rules, and we can now say run main. So let's see, does it follow the rules? And here you go, it now uses UV. So just simple things like that, always add it to the rule file so you don't have to repeat yourself over and over again. So what are some other things that you can use the rule file for? I have my rule file, I have a standard one, but I always make sure that it's specific to my project, to my standards, and what I am working on. This example rule here is a great place for someone to get started, but you have to fill it out with your specific needs and your specific use cases. Something that goes into every rule file that I create is this: keep it simple. It attempts to prevent Claude Code from over-engineering. It still over-engineers sometimes, so you have to be vigilant and really check that. You're not going to need it also for the same reason. I have my design principles. I have my file and function limits, so some basic coding standard rules. I have my architecture. I put in common mistakes that I see over and over again. I put in specifics about error handling, specific libraries and versions that I want to use, and any kind of critical mistakes that I see the AI do over and over. And here's 2 extra tips for you. When you are working on an agent project or an LLM powered project where you have LLM calls, Claude Code tends to overcomplicate a lot of things, and it tends to use excessive regex patterns or template parsing different parts of a prompt, and not really trusting the LLM in this process. Something that I always add when I work on an LLM powered project is I tell it to trust the model, Do not use regex, do not use templates. That really helps to get like a first version in so that you can then start building your guardrails after it's already working with just prompting. And the second one is, especially if you're early on in a project, Claude Code tends to build in really advanced error handling patterns like graceful degradation, or it even sometimes hard codes fallbacks, so that you might not even know that something is wrong in your code base when you run into issues. I always try it to fail fast and loud, and I always tell it to not hard code any fallbacks, especially in early projects. I rather fail with a clear error message to what went wrong so that I can go in and fix it. And one more thing, your rule file should evolve as your project evolves. So every week, ask yourself this: what mistakes did AI make repeatedly or more than once? What did I have to explain over and over again? And what patterns did I have to really enforce? What patterns didn't it follow when I prompted? And then add it to the rules and commit it to your repo so that also your team can share these learnings, or even make it into a ritual where your team can come together every week and you can discuss these things and you can decide together what you want to add to the rule file. So great, we know our tool and we have now taught the model our rules. But what about the prompts that you have to write over and over again? So tip number 3, store your prompts. If you write the same prompt twice, that's okay. But what about 3 times? Now it's probably time to store that prompt and make it reusable. You can store your prompts like code: versioned, reusable, and improvable. So I see people write over and over again things like add error handling to this function, write tests for this component with slight variations. They are basically reinventing the wheel over and over again. And worse, they're getting inconsistent results every time because the prompt changes slightly each time and they're not following a guided workflow. So you can always think about your reusable prompts as workflows, step-by-step guides that you want the model to follow when they are doing these processes for you. Treat prompts like functions. Write once, use it everywhere. In Claude Code, for example, slash commands are perfect for this. You can store your slash commands in a commands folder and you can reuse them. But you can use this in any tool. Just create the prompts folder, or other tools also have other ways of storing prompts. So just use the feature for whatever tool that you're using. For example, I have my tests. This runs a comprehensive test generation workflow. I have reviews, which triggers my code review workflow, or slash changelog if I just want to append the feature that we just added to my changelog. We're back in the repository, and here I'll show you one of my workflows. So you can see this is just a prompt to Claude Code to do a code review for me. So I just tell it here to please perform a code review, and then I can also add a review scope as an argument. And then it just goes my entire workflow, the review process, the focus areas, exactly what I wanted to focus on. Here you can see I also have the stuff about error handling in here that I went through earlier. And it also spits out a report for me in the end. So it will save this report into a markdown file for me so that I can go in there and I can cherry pick which fixes I want to make. This is also something I want to say here, like this could be a great starting point for you, but this is very opinionated and this is my workflow. Your workflow and your team's workflow might be very different. So make sure that it fits your need and your use case. Don't just copy someone else's prompt and expect it to work for your use case. You have to understand it and engineer it. You have to engineer the workflow so that it works for you. If you haven't already, start building your library of prompts. So I would like you to try this practice of every time you write a prompt workflow that works really well, save it, name it clearly, commit it to version history, and share it with your team. Explain to them how to use it, when to use it, and work together to refine it over time. Now, we are experts in our tools. Our rules files are really solid, and we have clear, reusable workflow prompts that we can improve over time. But before we even write a single line of code, there is something even more important that we haven't talked about yet. So this is tip number 4. Planning is everything. And if you only remember one thing from this video, make sure it's this one, because this one is really important. Time spent planning is time saved debugging. And it's not only saves you time from debugging, it strengthens your own understanding of the problem that you and the AI are working on. Here is a problem that I'm sure a lot of you have run into. When you're vibe coding or when you're not planning properly, you might ask AI to do something like build me a notification system of this to this existing project. AI generates something like 500 to 1,000 lines of code. It implements WebSockets, Redis queues, real-time async functions across different devices, and you have no idea what's going on. You have to then spend hours understanding what's going on and debugging it. And why? Because you didn't plan it. You did not spend the upfront effort that it takes for you to really guide the AI through the exact things that you want implemented. You didn't specify, and you hoped AI would read your mind and fill in the blanks. And it tried. So whenever I start to build something new, I always fill out some type of template similar to this one that you see right here. I fill in the goals of what I'm doing, the user persona of who I'm building it for, the use cases, the pain points, why am I building it, what impact and what value does this bring, detail about what I'm building, so technical requirements, and then success criteria. So I usually spend a lot of time making sure that both my success criteria and acceptance criteria are clear and measurable, because this will later allow us to do something really powerful that I will go over later on. I've also prepared one example. I have two different implementations done here. Simply what I asked it here is build me a script to organize the files in my downloads folder. Then I had one other one here that is called planned. So here I'm telling it very specifically what I want done. I'm telling it to build a file organizer for my downloads folder, sort only files with these formats. So I'm specifying which formats I want, which folders I want it created. I want it to move files into specific folders. Single Python file, no dependencies. A little bit of a comparison here. Without the planning, we had 137 lines of code. With planning, we had 57 lines of code. And we also had a lot of AI assumptions in the Vibe version. 10 file categories instead of the requested 4. Complex logging system with file outputs and timestamps, which is maybe it's useful, but it's not what we asked for. Way over-engineered. We might not want this. We might want to handle these namings differently than what it assumed. Cross-platform downloads. This is a one-off script that I would run once. I do not need it to work for Windows and any other platform. I use a Mac. I need it to only use for Mac. And it also has extensible architecture with type hints and modular functions, which is okay, that's cool, but we don't need that. We can see here the difference with the planned version. It strictly followed the plan, exactly 4 file types, 4 folders only, skipped any existing files. It prints the summary, one single file, 50 lines, very clean, very focused. This is how you get reliability out of AI coding. Be very specific about what you want and very specific about what you don't want, so that you can trust that the AI will do what you need it to do. Nothing more, nothing less. So you can use AI to help you to plan. So you can create a prompt for AI to dig into your code base, find out where is the best place to put this feature, how should we architect it, what else from the code base could we use to build this, can we reuse components, functions, utilities, you name it. And while AI is doing that, you can also do it in parallel, so that when AI comes back with the result for you, you can compare that and it will help you scale up your planning. I do this and I run up to 8 parallel AI planning modes in parallel, looking at different parts of the problem. I can even vibe code together one, see if it works, and then roll that back and create a proper implementation plan for AI to follow. The planning really is critical, and it is one of the most important things. But there's one other important thing that we need to talk about, and it's the mind shift change. So tip number 5, change your mindset. The fundamental part is that you're not the only one writing the code. You are instructing AI, or you're conducting AI how to orchestrate your entire development process. AI is not only writing your code, it's also helping you planning, it's helping you debugging, and it's helping you review the code as well. So you can really scale up everything you can do and also allow you to do a lot of these things in parallel. So something that I see a lot running my workshop is that a lot of senior engineers are very skeptical of AI, and they struggle a lot working effectively with AI because they're so used to writing every single line of code and really going through every line of code themselves when they are reviewing. What's needed here is a little bit of a mind shift change. Make sure that you can prepare in advance so that you can trust the output, and there's other things you can do after the AI run is done to validate the output. You don't have to sit there, check every message that AI is writing. You can send AI off on a long running task, and only once it's done, you can go in and you can review that. You don't have to check everything that AI is doing all the time. You can think of this as a manager. If you gave your junior developer a task, you wouldn't go in and review it after every line change that it does. You would give it a task, you would give it all of the plan, the context, the goal, everything that he needs to prepare the task. And when they're done, they would put up a code review or a PR for you so that you can review the code. And it's no different with AI. How do you succeed as an AI orchestrator or an AI conductor? With AI, you have to define exactly what to build. So what we talked about in the planning section. You also have to specify how exactly you want it to work, set the standards and the patterns, and you have to also at the end review and validate the output. You can do this for multiple features and multiple products in parallel. While AI writes code for one feature, you can plan the next one. Or you can even build a UI and the backend in parallel, or you can build two projects at once. You can really scale this up as much as you want. And what you need to think about now is that you are not only a product manager or not only an engineer, you have to be both. And you can even argue that you have to be the designer and the analyst here as well. And you have to really specify what we are doing and also why we're doing it, and also exactly guide the AI into how we're doing it. So that's where that workflow patterns comes in. You can really get specific and guiding AI in the how. And this really has a multiplication effect. When you truly get this and when you understand how to parallelize this, then that's when the magic happens. Something that I regularly do, I have one AI or one instance of Claude Code building the back end. I have another one building the front end, and I have a third one planning my next feature in that project. And I might have a fourth one or a group of fourth ones working on a second project or even a third project. I have sometimes ran up to 12 parallel instances of Claude Code. Now there are some limitations to that and a lot of pitfalls that you need to look out for, but more about that in another video. Now we have learned that also conducting is powerful. Conductors, they also need their sheet music to be successful. So how does a conductor know that the performance that they just put on was successful? And that comes with validation and feedback. Tip number 6, plan your validation. Before you generate any code, really think deeply about how will I make sure that what I'm attempting to implement really works the way I need it to work. If you can't validate it, you shouldn't generate it in the first place. A lot of people, when they generate code, write an unclear instruction for the AI, they generate it, they run it, and then hope that it works. And when it fails, and they're not even sure what is working and why it's working, they're blaming the AI and they're telling AI cannot code. And this is gambling. This is not engineering. Before you write the prompt or before you try to generate the code, think about this. What tests must pass? What user actions must work? What edge cases do I need to handle? And what performance metrics matter to me? And then, this is key. How can I let AI validate that itself before it comes back to me? And then you tell AI, run all of the validation and make sure that all of the requirements are met so that we can be sure that it works before AI has completed. This is what makes AI agents and AI coding assistants, especially Claude Code, extremely powerful. So here we are back in the repo, and I'm going to show you the validation strategy that I use and that works for me. I have 4 levels. So I set up my linting rules and I make sure that it follows my standards by running the linter and fixing any issues that it has. The second one is the unit tests. So here I very clearly define what I want tested when I write my prompt, and then I have it run all of the unit tests until it passes. If it runs into issues, I have this root cause analysis command that I wanted to follow. So this is again just the workflow of how I wanted to do the root cause analysis. This is also shared in my PRP repository. I'll put a link somewhere. You can go in and look at that command in there. The third step is integration testing and system validation. So here, there are a few different tactics you can use here depending on the project you run. So for Python, or if you're building an API, you can use curl, for example, and you can use a bunch of different tactics here depending on what you're building. So think about how would you implement it yourself? Like how would you make sure that it runs? Then think about ways to allow AI to run it themselves. So here you can use some really creative methods, but you have to be careful to make sure that the AI can run it itself, like as a bash command. If it's an interactive bash command, it will get stuck. So you have to instruct it which ones it can run and which ones it shouldn't run. And this is where it comes to level 4. So my fourth level is where I put the creative or domain-specific validation. So here I like to use, if I'm building a front end, I use the Playwright MCP server. This will allow the AI to open up the browser, get the console output, take screenshot, click buttons, check elements, really do a lot of powerful things in the front end. So this is really powerful if you're building a front end. Any kind of database MCP, so if you're using something like Supabase or Neon, you can use those MCP servers. Or if you're just using Postgres, there is a Postgres MCP that you can use as well. And there is really a lot of things you can do here. So any CLI that you can use non-interactively, the AI can also use. So you can use things like Bandit. There is a lot of things you can do here, and this is really just scratching the surface. So here you can really get creative of how you want AI to validate itself. Then I have one more step that is not listed here, but I always run human verifications. So this is something that you also should do. Always test AI generated code, always review AI generated code, but you can use AI to do a lot of that itself so that you can have more trust in it when you get to the human part. Once all of that is done, I also have a final validation checklist that runs all of the final validations. Here is like my entire standard prompt for most anytime I want to do a new implementation. I fill this type of template. In here, we have all of those validation steps. I also have a / command for my validations. If I want to run validation on any specific thing, I can just run my repeatable / command, reusable workflow. Same thing we talked about before. Make sure that your prompts are reusable so that you can use them over and over again and that you can improve them with time. So if I want to run any kind of validation, I just run my / command and I will do it whenever I feel like I need to. So now you have all of the important pieces that I see working time and time again across tools, across models, across model updates. The last step now is how do we put all of this together? To tip number 7, and this really is where everything clicks. When you combine these principles into a systematic workflow, you really go from struggling with AI and struggling shipping production features with AI, from allowing AI to ship production ready code in one pass, like in one long implementation. It will really allow you to have AI run from 10, 20, 30, maybe even up to an hour reliably, so that during that execution time when AI writes code, you can go and do other things. I regularly do things in parallel, what we have talked about before, or I kick one of these workflows off and I go take a walk with my dog. I have it running during my lunch break. Maybe I even have 4 different versions of the same implementations running during my lunch break. And when I come back, I can just look at all of them and compare them, and I can decide which one I want to move forward with. So here is the full workflow that I use and that I teach. This is also the same principles as I use in my PRP framework, which is product requirement prompts. I have a bunch of other videos on that you can check out. I'll put the link to one of them up here if you really want to deep dive into how PRP works and how you can get deeper into that. Coming back, step number 1, planning and exploration. Define clear objectives, define clear acceptance and success criteria, and define your scope boundaries. Be specific about what AI should be doing and also what AI shouldn't be doing. Then gather all relevant context, gather all of the documentation that it needs, example implementations, utility functions from your code base, patterns from your code base that you want it to use, and also the dependencies that you want it to use. Then spend time designing your validation gates. Things like define your test cases beforehand. You don't have to write the entire test case, but you have to be explicit to the AI what it is that you want to test and why you want to test that. And also make sure that you create really clear, measurable success metrics that you can verify, but also that the AI can verify. I usually spend up to an hour for each task that I want to do, preparing all of this. My tasks are not that small, like I don't do it maybe for a single Jira task, but I rather do it for an entire feature end to end. That is why I spend so much time upfront. So when you start out with this, maybe you want to start with a simpler task from your backlog, follow all of these steps and try to do this for a smaller task. And as you get better and better at crafting these workflows, you can really scale up the amount of work you can get done in one pass. How do I spend my time here? Let's say that I'm spending an hour on all of these things. Maybe I spend 30% of that time in the planning stage, and then I maybe spend another 30% of that time in the context gathering phase. But here I also use AI a lot in these two steps. I use AI to help me plan and to brainstorm. AI also help me gather context, especially it's really good at gathering context from your code base, but it's also really good at helping you research the web. And you can research the web in many different areas of the web in parallel using either sub-agents, or you can just use several instances of Claude to go and look at different places. And then maybe I spend 20% of the time on the validation design. There I really try to craft validation designs that the AI can execute themselves, so that I can trust that the AI will have run those and validated those before it tells me that it's done and it hands the review back to me. And then I spend about 10% of this time crafting the prompt itself, because I have most of my prompts already written. So it's really just templates that I fill out based on the specific task that I will be working on. So I take planning, context, and validation, and I put it into my prompt or my workflow template. So I really don't spend a lot of time creating the actual prompt, because I've already defined reusable workflows that I can use for that. And then as I have prepared all of this, the execution itself, stop for a second and think about it before you execute it, and ask yourself some essential questions here. Could I complete this with all of the context and this prompt, like this workflow? Is this a good instruction? And if I follow this to a T, would the task be done? Are the requirements crystal clear? Have I referenced all of the correct parts of the code base that I want it to be touching? And have I provided all of the necessary context for it to be successful? Will the test prove the functionality? So the test that you have defined and that you have engineered beforehand, will they actually prove that it functions the way you want it to function? Do the linters ensure the code quality, and do they follow your teams or your coding standards? Are all of the success metrics measurable? If all of these answers to all of these questions is yes, it's safe to execute. And here, really, this is where I spend the least amount of time on the execution itself. I usually just write /execute, which is my execution workflow, and I pass it the plan, the prompt, the workflow that I want it to execute. And then I put that away to the side. I do something else for the 30 minutes to an hour, hour and a half that it will take it to do that implementation. When it's done, I get a notification on my phone with my hook. I go back to that, and then I can check and I can review the output. If it doesn't work, I have a few options. I can either follow that path and try to correct what doesn't work, or I can roll it back and I can adjust my plan and my prompt, and I can identify where it went wrong and I can adjust that in the prompt, and I can then run it again. If you're still skeptical, or if you are not sure that you can get this to work, I have something for you that you can test. I have a challenge for you. If you haven't gotten AI to work accurately for you, or if you don't really get the results that you want out of AI, or maybe you are already using AI but you want to use it better, try this out. Pick an existing task that you have, maybe from your backlog, or a new feature that you want to implement into your code base. Spend at least 30 minutes following all of the steps in tip 7. So do the planning, do the context gathering, do the prompting, create your validations, make sure that you have everything the AI needs to succeed, and then create a workflow prompt for the AI. You can use my PRP template, but you can simplify it. You don't have to follow everything there. Just use the key details from this video and then send the workflow. While you have AI doing that in one terminal window, try to implement the feature yourself, because you should also have all of the knowledge by that point to implement it, to actually write the code yourself. Then you can compare who did it faster, who did it more completely, and then you can also compare the code quality. And you can see, did AI fill your needs? Did AI actually succeed at what you set out to do? Did it do it better than you? That will be a good exercise for you to see if AI actually can code. This was a little bit of a different video that I did. Do you want to see more deep dives into these kind of like tips and tricks, how to use Claude Code, how to use Cursor, how to use these different tools and my tips around that? Or would you rather see more deep dives into PRP itself and how I prepare a prompt, how I work on an existing project, maybe how I work on a new project from scratch? So let me know down below in the comments like what you want to see out of this channel. Also tell me about your best tips and tricks. Let me know down below about, do you agree with these tips? Have you seen something else that works better? I'm always down to learn, so let me know in the comments how you use AI and how you use AI successfully. Also let me know where AI fails for you, and maybe we can address those issues together. So that's it. That's my 7 principles that I have learned over the years and that I see other product teams use successfully on production code bases. So you can now keep vibe coding, or you can keep denying the value of AI, wondering why it doesn't work, or you can join the teams that ship 10x more efficiently with half the team size. The tools will change, the models will change, but these principles that we talk about here, they are the ones that will remain. And if this helped you, please give me a thumbs up, subscribe. Now, stop watching this and start shipping features, and I will see you in the next video.